Hello everyone. In this session we are going to discuss in detail about adder circuit. So first of all we'll see the half adder circuits. It is the combinational arithmetic circuits that adds two binary numbers. It is the basic building block of any ALU circuit. So in the half adder circuits there are minimum two inputs. So maximum possible combination for these will be 4, that is 0 0 0 1 1 0 and 1 1. So the output of the half adder circuits will be sum and carry. Sum will give the addition and carry will be the carry. Next, this is the truth table for half adder circuits. So as per this, the sum that will get generated will be 1 1 when the inputs are, when any of the input value is 1, and if the input value is not 1, that means if both the input are 0, then the sum that will be generated will be 0 and carry also will be 0. So as you can see that when A and B values are 0 0, the sum is 0, carry is also 0. When A or B, if any one of the value is 1, so in the second step and the third step, the second step has the value B equals to 1, whereas the third step has the A value equals to 1. For both the cases, the sum that will get generated 0 plus 1 or 1 plus 0 will be 1. And for the last case, 1 plus 1, this is the important step where sum that will get generated will be 0 and carry that is being getting generated is 1. So this is the important step. Excuse me. Next, this is the K-map representation for the sum. K-map representation for the sum. Let me use the pen. Hello everyone. In this session we are going to discuss about half adder circuits. It is the combinational arithmetic circuit that adds two numbers. So it is the basic building block for all the ALUs and processors. So let us start with the session. This is the basic building block of Hello everyone. In this session we are going to discuss about the half adder circuits. So it is the combinational arithmetic circuit that adds two binary numbers. So this is the basic building block of any ALU circuit. Let us see it in further. Hello everyone. In this session we are going to discuss about half adder circuits. Half adders are the combinational arithmetic circuit that add two numbers. It is the basic building block of any ALU circuits. So let us discuss the half adder circuits in detail. This is the block diagram of half adder circuits. It has two inputs, variable A and B, that stores two different input values, input binary values such as 0 0, 0 1, 1 0 and 1 1, and this output that is being generated by the half adder will be sum and carry. Sum is the addition of two numbers at the input side of the half adder, that is A plus B, and the carry will be generated as per the addition of these two numbers. These are the truth table. So when the input A and B, these are the variable where these different input combinations are being stored. So as there are two inputs, the maximum possible combinations will be 4, that is 0 0, 0 1, 1 0 and 1 1. When the input value A and B are 0 0, at that time sum will be 0 and carry is also 0. If any of the either two input is 1, then the sum that will get generated will be 1. As you can see in the second step, as you can see here in the second step, let me show you. Okay, so here in the second step, the B input is 1, whereas for the third step also the input is 1. So when these type of condition occurs that any of the input value is 1, at that time the sum that gets generated will be 1 and 1, as you can see, and there will be no carry further that will get generated. And this is the very important step. When A and B inputs are 1 1, at that time sum will be 0 always and carry will get generated. So this is the truth table for sum and carry. Let us see the K-map for it. This is the K-map representation that will help us to find the Boolean expression for the sum and carry, and these expression will further help us to draw the logical circuit for sum and carry. So let us see here. So this A bar here represents 0 value and this A represents 1 value. Similarly here this represents 0 value and this B represents 1 value. So now as you can see that when the input value is 0 0, that is A bar B bar, at that time sum is equals to 0. As you can see that when A and B are 0 the sum here is equals to 0. So we are just bothering for the sum values for these two input variables. So when it is 0 0, the sum here is equals to 0. Okay. So when the input are 0 and 1, at that time, if any one of the input is 1, at that time the sum will be 1. So here it is being shown that sum is equals to 1. Similarly, when the input is 1, this 1 and 0, that is A and B bar, at that time again the sum will be 1 and carry will be 0. So we are not right now bothering about the carry. So this is what the sum is equals to 1 when A and B bar, that is 1 and 0 input value is there, at that time sum will be equals to 1 and carry is 0. And when the sum is 1, when the input are 1 and 1, that is 1 plus 1, the sum that will get generated is 0. So here it is actually 0. This is the value 0 and carry will be 1. So we are just making an equation for these value 1 wherever it is 1. For that we'll make the equation. So you can see that sum equals to A. So how to write the value of sum? So see, for this one, let me show you again more clear. So for this one, at the bottom side 1, the equation will be A and B bar. So the equation will be A and B bar plus for this one, the equation that we can write will be A bar B. So this is nothing but the equation for XOR gate. As we know that equation for XOR gate is A into B bar plus A bar into B. So that is the equation for XOR gate. Similarly, we'll find the K-map for carry. We'll write the expression as per the truth table and the K-map. So we know that when the combination for the input are where 1 and 1, that means here the value is 1, this is 0, this is 0 and this is 1. So as you can see that this one and this one, it intersects at this place. So when the input combination is 1 and 1, at that time only the value will be 1, except that all other places the value will be 0. Now how to write the expression for this? So check for the left hand side variable. Check for the left hand side variable, it is A, and check for the top variable. So it is B. So this is nothing but the operation of AND gate. So carry will be equals to A into B. So this is the equation how we have to find the equation using K-map. So from this equation we can write that sum is equals to A XOR B. Sum can be written as A XOR B, whereas carry is being written as A into B. So now for this XOR we have used this XOR gate, and as this is the multiplication we have used AND gate. So this is how with the help of these Boolean expression, the logical diagram or logical circuit can be used, and by using these gates we can able to add two binary numbers, and this is the basic circuits for half adder circuits. Okay, thank you.